This video describes the solar system view, one of three major views available in the Tidewater Planetarium program. The other two views, the dome of the sky view and the full sky view, depict the sky as seen from Earth at particular dates and times and in two different projections. By contrast, the solar system view displays the objects modeled in our solar system as viewed from out in space rather than from the Earth. This view does not depict the background of stars or the Earth's moon, but all of the other objects in the solar system model are available for display in this view. As we can see here, the Earth itself is in the view, along with Venus, Mercury, and Mars. So in this example, we're looking at the inner planets of our solar system, the rocky planets. And we can see several things. We can see the objects themselves depicted as colored dots. We can see their names. We can see representation of the orbits that they're on. And we can see a frame of reference. I'm going to describe the frame of reference here for a minute. There are four axes displayed in the plane here of the Earth's orbit around the Sun. That's called the ecliptic plane. These lines each lie within that plane. The red one represents the direction of the vernal equinox, or the spring equinox. That's the direction in which you would see the Sun from Earth on the day each year where the Sun passes over the Earth's equator on its way northward. That's usually around March 21st each year. And that is a standard astronomical direction, so that's what's represented by this red line. There's another red line stretching upward from the Sun. It represents the northern perpendicular to the ecliptic plane, which is also a standard astronomical direction. So taken together, these lines represent a framework within which we can view the solar system objects and their orbits. Another thing I'd like to point out is that the orbits appear to be brighter at the front and dimmer at the back in order to create a sense of depth perception and give you a sense of perspective on the objects and orbits that you're looking at in this view. Each of the solar system objects and their names can be optionally turned on or off. So for example, we can turn off Venus's name and orbit. We can do the same for Mars, leaving us looking at just the Earth and Venus, but the objects themselves remain in the view. Now I want to demonstrate that we can change the direction of our view by holding down the mouse button. The left mouse button will give us a course control, so if we hold it down and drag the cursor, it will tilt our view and rotate our view to our preferred angle. The right mouse button does the same thing, but with a finer control. This gives us the opportunity to look at the orbits angle on or from directly above if we wish. And we can see their relative size. In this case, both of these orbits are relatively circular, so they're pretty symmetrical to each other. If we now add Mercury's orbit, we can see that its orbit is somewhat more unusual, coming close to Venus on one side of its orbit, but being quite far from Venus on the other side because it's a fairly highly elliptical orbit. We can also tip down and see the relative angles of these orbits, that they aren't all in the same plane. The next control that I want to demonstrate is the ability to zoom in and out in the view. So the easiest way to do this is just by rolling the mouse button backward to zoom out, forward to zoom in. There are also zoom controls at the top of the screen. So let's add a couple more orbits to our display. Let's pick some that are far out, like Pluto. And let's just start with that and zoom out until we can see Pluto's orbit. Pluto is so far out that we have to zoom way out before we can even see its orbit. And once we do, we can barely see the orbits of the inner planets, giving us a perception of just how large Pluto's orbit is compared with the inner rocky planets' orbits. Now let's add another solar system object, Comet Halley, and see its highly elliptical orbit compared with the other orbits in the solar system. We can add the planets Neptune, Uranus, Saturn, and Jupiter, and we can see that except for Pluto, Comet Halley stretches well out into the solar system, and on this date and time, which is in 2017, Comet Halley is almost out at the extreme end of its orbit, farthest from the Sun that it's ever going to be. So this gives you an idea of the kinds of views you can see in the solar system view using Tidewater Planetarium. There are all kinds of things that you can learn about our solar system using this feature of the Tidewater Planetarium program.